Okay. Hello, everyone. My name is Kalen, and I will be showing you how to do a couple problems within homework 5.3, which is about transistors. So these are the two homework problems that I decided to go over. Um, the math is pretty straightforward, but once you understand some of the concepts, um, it'll be a lot easier, I think. So for this first one, the thing you need to remember is that an NMOS is going to be an open switch unless this threshold voltage is met. So this problem really is just deciding if the voltage at this node is greater than 1 volt or not. If it is greater than 1 volt, then the NMOS will act like a switch and it will be a short, letting current flow through it. Else, it's going to be a open and it won't let any current pass through. So to find the voltage at this node, I'm just going to do quick current voltage division. You're going to do 25 over 100, which is 75 plus 25. This is all in kilo ohms. And then you're going to multiply it by Vn, which is 3.5. And so when you do that, you'll get 0.875. Which is not greater than our threshold voltage of 1 volt. And so this NMOS is going to act like an open. And so similar to the problem above, we have NMOSs and PMOSs. And so this problem isn't really necessarily concerned with calculating values. It's just testing to see if you understand the difference between PMOS and an NMOS. So like I said before, an NMOS is an open switch until a voltage is applied, and then it will be a closed switch, meaning a short. The opposite is true for PMOS. So PMOS will act like a short unless a voltage is applied that's greater than the threshold voltage, and then it will act like an open. So, like I said, this problem doesn't have values associated with it, so we're not asking you to calculate any values. We're just going to see at the different combinations whether these switches are going to be open or closed. And then we're going to see how that affects our output, the out. So I think the problem with this problem is that it's kind of a rat's nest because it's hard to follow these lines. So I like to write what actual voltage it associates with right next to the gate. So I know that these two are VB, and this one is going to be VA, and that means this one is VC. Along with this is VB, VA, and VC. So just going through all the different combinations, we know that the output is either going to be grounded, which means it's going to be 0, or it's going to be equal to VCC. And so looking at this first combination, we have A, B, and C. So if we have A, B, and C all active, we know that this is going to be a short along with this, and this. And then these up top are going to act like switches, open switches. And so no current is going to flow through the top half of the circuit, and all of it's going to flow through the bottom half. So the key to this is just seeing all the different paths current could flow through and saying, does that go to ground, or does current go, or is there a connection to VCC? So I noticed that these two are VB, and VA and VC are also connected. So if there is a path, it's going to be either one of these two ways that it can go to ground. And so one of the combinations that it can happen is it can either be VB and VC, that will ground V out, or VB and VA. So right off the back, I know that anything with VB and VC is already going to be 0, along with anything with VB and VA are also going to be 0. So we know that these three are going to be 0 because if we look at it, there's a path from V out straight to ground through this open channel. And similarly with VB and VA. Now let's take a look at some of the other border cases. What if VA and VC are on? Well, we know that if VA and VC are on, we know that, well, this top half is going to be an open right there and right there. And these associate with the closest transistor. But we also know that these are going to be a short. The only problem is there's still no way for V out to get to ground here because it's blocked by this open switch. However, there's a clear path right there. So we know that this is going to be VCC. So I hope that kind of makes sense, that we're just looking for whether switches are going to be open or closed. And these two halves are just going to mirror each other. So if something is open on the bottom, it's going to be closed on the top, and vice versa. So going ahead through this problem, we have VA. So this is going to be an open. But yet again, currents can still flow through here. So this is also going to be VCC. We know that no current is going to apply here because this is an open. And likewise over here as well. Okay, what about our next example? So the next example is going to be VC is open, which means this one's closed. This is still open. So once again, current loves that top. And so it's going to go VCC right there. And if none of them have a voltage applied on them, that means this entire top half is just going to be a short. Here and here as well. So that's kind of how I like to approach this kind of problem. Realize that PMOSs are going to be a short until they're opened. And the opposite is true for an NMOS. An NMOS, it's going to be an open until it's a short. And so that can help you as you try to solve these problems. Good luck on the midterm.